Hello, my dear students, and welcome to our final semester in your graduation as an electrical and communication engineer. This is Samah Abdul Latif, the module leader for the Optical System course 20ELEC22H. This is our first lecture. Actually, this is our zero lecture in this Optical System course. This is, as I mentioned, a final semester course. So please expect a course more toward application, more toward commercialization, and more toward markets. Our course is somehow an extension to your electronics, semiconductors, materials, electromagnetics, microwave, antenna courses. Maybe also we can say it as an extension to your communication, industrial communication course. So in the optical system course, we will have a multidisciplinary perspective toward different optical application, considering optical communication as one of the most important applications, specifically when we are talking about optical fibers. Also, we are going to tackle somehow electromagnetic point of view when we are considering the optical cavity. And whenever we start to learn about lasers, we will have to recall our semiconductor as well as our material background. So as I mentioned, it's somehow a collection between different backgrounds. Now it's a final year course. That's why we will make some effort toward what we can call it to commercialize our course. I mean, to make this course somehow a bridge between your theoretical academic study and your future market. So for those students who are willing to work in the field of networks, optical communication, optical fibers, and so on, please do a lot of effort in participating, concentrating, and studying this module, especially the first part, where we are going to do some investigation in the optical fiber design and the main optical fiber calculations as well. Now, let's start our 12 weeks journey by considering this zero lecture, where we are going to demonstrate the main course outlines, the main assessments, the time plan, the lecture materials, the tutorials, and actually also the project. All these will be considered in this zero lecture, where we can stand on the same ground, starting to reach our first lecture dealing with optical fiber. Now, let's start sharing my presentation slides and let's start our journey. Okay, welcome back to this introduction or course outlines lecture. As I mentioned, in this lecture, we are going to make a very brief introduction to the course outlines, assessments, the materials, and all this stuff. So let's start with what is an optical system or what is an optical communication. Actually, the results was about 140 years ago by a very famous scientist called Alexander Graham Bell. Alexander Graham Bell was the first one who used the optical signal to carry a message. When he starts to speak, as you can see here, and there is a candle here, and his voice vibration is now transferred to the candle in a form of waves, and this wave is then transferred, as you can see, to a detector, and this is a membrane, and this is a mirror where you can detect the changes. So typically now, Alexander Graham Bell's voice is the message. The light emitted from the candle is a carrier signal. This is an optical carrier signal from the transmitter to the receiver. And this is somehow of what we can frankly say, this is somehow an optical amplitude modulation, where the amplitude of the optical signal is varying while Graham ball is talking. And then this is a detector, and here is the receiver. This is the primitive, the first initial optical system across the world. Now, the concept is very easy. You already know this concept 1, 2, 3 semesters ago. The concept is that we have a message, and you have a carrier, and then you have a modulated signal. The message is some sort of data, random unknown data we are not interested in. However, we are always interested in the carrier. And based on the frequency of the carrier, you can determine the type of your modulation or your communication system. I mean, whenever we are using an RF carrier, then that's mean that we have an RF communication, or what we can call an RF transmitter and an RF receiver, or generally RF transceivers. Whenever your carrier frequency increases to be in the optical range, then we have what's called an optical communication. And then we have an optical modulator and the optical demodulator, which is a concrete part of this module. So simply, for a communication system, we have a transmitter, we have a channel, and we have a receiver. But for our optical communication system, we have an optical modulator or an optical transmitter. We have an optical channel, or a channel that have a capability to transmit optical light, and then we have a receiver by the end of the day. Mainly, I would say that all our code, the 12-week, will be consumed in these 3 blocks. How to have an optical modulator, an optical carrier, because as you know, the modulator has 2 inputs, the message, the carrier, and then this is the modulation process to get the modulated signal. So our course will concentrate on how to make an optical modulator, how to generate an optical carrier, how to transmit this signal over a channel, and how to detect the signal. This is generally the outline of our course. So historically, the first challenge is to have what's called an optical carrier, an optical frequency which can carry the signal. If you recall your communication courses, especially your analog communication courses in year 2, you remember that one of the main characteristics for a carrier is to be a monotonic, a monochromatic. I mean, to be a single frequency, a sinusoidal signal. A sinusoidal is famously characterized by that it's a single frequency signal. The same can be applied here. We need to generate light, but not any light. We need to have a monochromatic light, a light which includes a single frequency. The answer was here. The answer was by Bennett and his team when they first invent what's called a laser. So the main characteristic of a laser is that laser is a monochromatic light source. I mean, laser include theoretically only a single frequency, and this is typically the characteristics for a carrier. So this is the first challenge. Again, this is the first challenge to have an optical carrier so that you can make the optical modulation process. But there is still another challenge, which is the channel. Here you can stop for a while and ask why there is a problem. Light can propagate in air, so you can typically use air as an unguided medium, like the same way like the same while we are using RF communication, for example, mobile communication. This is an RF communication where you are using the air as an unguided medium. This is typically true, but you have to remember what's called the line of sight. In the optical communication, in order to use air as a medium or as a channel, unguided channel of course, then a line of sight between the transmitter and the receiver is necessary. Whenever there is an obstacle between the transmitter and the receiver, then you lose the connection between the source and the receiver, and then you lose your channel, or you lose your message. So this is the main obstacle. This is the main problem while dealing with an optical communication. By the way, one of you may ask a question, why we are using optical communication? We are already satisfied with our RF communication. We are happy with having this 2.4 or 5 or 6 gigahertz frequency. Why we should use this 100 of terahertz frequency as a carrier? Here, the answer will be in the next lecture. While we are introducing the optical fiber, we will introduce the advantage of using optical communication or optical carrier with respect to other RF carriers. But now let's turn back. Here the problem is that we have what's called a line of sight. The line of sight is a must. We should have a line of sight in order to guarantee the transmission of a message. Otherwise, the message will not be transmitted. Okay, so our second challenge was the channel. Using air is limited to line of sight. However, in order to get rid from this line of sight restriction, you have to have an alternative. I mean, you have to have a guided alternative. Like we have a coaxial cables, for example, in the case of an RF communication. We need a guided medium where we can transmit the optical light. And the answer was by Conan Co. Conan Co has discovered or has invented the first simple optical fiber where you can transmit light inside. And this will be our topic for the next 3 weeks, by the way. Okay, so the main 2 pillars for an optical communication system is the laser and the optical fiber. The laser is considered the carrier optical frequency, the monochromatic light. And the optical fiber is considered as a guided medium where this light will be transmitted through. Lasers. What is light oscillation by simulated emission of radiation? It's some sort of oscillations or some sort of oscillators. I believe you already studied oscillators in your second year in the electronic courses. These circuits capable of generating AC signal from DC signal. This is the oscillator in the electronics. And in the optical manner, laser is some sort of an oscillator. However, when they start to abbreviate it, they found that it will be abbreviated by loser. That's why they turn it to be light amplification by stimulated emission of radiation. However, the word amplification is not 100% correct because there is a main difference between the amplifiers and the oscillators. Amplifiers is a stage of amplifying an input signal. So you have an input signal, and then this input signal is amplified to some extent to get an output. However, oscillators has theoretically no input, or between quotation, it is seeded or it is faded by noise signal. But to make it somehow more prestigious, we start to use the word laser instead of loser and say that light amplification by stimulated emission of radiation. However, optical fibers is a very, very important innovation in the optical communication technology. But we still need air as an non-guided medium in case of optical communication. This is typically happen in the satellite communication, because in the satellite communication you can guarantee in a very easy manner the line of sight between the transmitter and the receiver. The transmitter and the receiver, the transmitter is located in the earth, and the receiver is located in the space, or vice versa, because both are transceivers, by the way. So they can see each other's all over the time, as far as the synchronization between the satellite and the Earth rotation. So this is one of the very important applications where the air is still used as an unguided medium between the transmitter and the receiver in the optical communication. Of course, laser is not only a optical carrier. This is a single, very limited application for a laser. However, laser nowadays is in everything, in material production, in medical treatments. You can find laser in every and each segment in your life. Everything includes lasers, even when you are going to play, even for the module leaders to marker their whiteboards or their presentation. Everywhere you have a laser. By the way, there is a huge difference between this laser we used in our classrooms and these lasers used in the optical communication or in medical treatment or something like that. And the main difference here is the power. This is a low power laser, and the other is a high power laser. Okay, so optical fibers. This is just a very brief slide about it. As I mentioned, we will spend something like 3 weeks in dealing with optical fibers. So this is just a brief introduction. But optical fibers is very, very important everywhere. We use optical fibers in many different applications. I believe most of you hear about the rechanging of the infrastructure in the public central telephone network in Egypt, for example, to replace these old coaxial cables by new optical fibers. And everywhere we have an optical fiber. So now optical fiber is an important element in any infrastructure for any new city. Also, we have another type of light sources. It's not only laser. We have what's called the light emitting diodes. Most probably, we will not have enough time to study the light emitting diodes in depth. This maybe happen for those students who selected optoelectronic courses as an optional courses. However, in this year, we don't have optoelectronic module, but generally the light emitting diodes are a part of an optoelectronic courses. And also we have what's called the receiver or the photodetector. Maybe we can consume a very few slides about it later on, but this is the most famous detector for the light, either emitted from light emitting diodes or emitted from lasers. This is another example. Okay, so we have more and more. We have what's called the photonics. Photonics is somehow some sort of modern optical devices, which is based on the variation of refractive index for different material, and it has a very, very interesting and famous optical behaviors. Of course, this is somehow advanced optical topics, and of course, this is not included in our module. And also, we have a very important term nowadays is what's called the IOs. We already know what's called the ICs or the integrated circuits. Now we have what's called the integrated optics, how we can integrate optical devices in a small compacted area, like the same we did for the integrated circuits of the ICs, of course. Okay, so I believe this is a very famous map. You already see it more than once before. This is my map. I usually use it for demonstrating the curriculum, your curriculum. Here is the track for the electronics, and now we reach the final stage, because now, as I mentioned, no optoelectronic courses is delivered in this semester. So This is the final stage with the optical system course. This is somehow makes sense because you are now in your final semesters, inshallah. Okay, and I'm sorry. Okay, so I believe you already know me. I'm Usama Abdul Latif, the module leader for this module, and it's a pleasure for me usually to have Engineer Mira Mohsen as a TA for this module. It's now, I believe, 3 years together we are learning this module. About the course content, yeah, actually, when I first start to deliver this course, I consider starting the course with chapter 3, which is atomic radiation. I start with atomic radiation, then laser, and then I terminate the course with an optical fiber and optical communication, which is optical modulation and optical demodulation. However, after a while, exactly in my third iteration, which is the last year, because this is my first one, in my third iteration, I start to rethink about shuffling the course somehow. This is simply because of two main reasons, actually. The first one is that the optical communication part is much easier than the atomic radiation and the laser part. So it's better to start with something easy to make some sort of smooth start to our module. The second issue is that what I mentioned in the first of this lecture, what about the commercialization of the module. I mean, we need this module to be more toward the market. It's a final semester module, so it should be somehow directed to market. That's why I prefer to give a huge boost to what's called the optical fiber technology, because most probably for those who are going to make interviews for optical communication or communication for network, any of these stuff, they will have some of the interview about optical communication and optical fiber. That's why I start to make this first part of the module, so you give them a special concentration. Usually the first chapters are more lucky than others because you can study it more than one. So that's why I prefer to put the optical fiber and the optical communication in the beginning of this lecture, in the beginning of this module. I believe that this makes module much easier than the first arrangement. You never know, but this is my belief so far. Okay, we have 3 types of assessment. As usual, we have an in-class test, which is scheduled to be in week 9. We have the project, which will be submitted in week 12. And we have, of course, the unseen exam, which is 60%, 70% weighted in the end of the semester, inshallah. The e-learning arrangement. So let's now have a very quick tour to see what we include in the e-learning and in the time plan of the course. Okay, so this is our e-learning. As usual, we have, of course, the module specs exist here. We have also we have here the weekly time plans. This is somehow an important document to show. Okay, yes, this is the optical. This is the document. So as usual, this document includes every and each session. By the way, all of our sessions will be online because we don't have any practical on campus. That's why we have our tutorial as well as our lecture online, as you can see here. So you can find everything. Your first deadline will be in week 3 in order to select your group and your project title. I will discuss somehow the projects in a few seconds or minutes. Then we have, I think we have 3 milestones in week 5, week 7, and week 9. No, I'm sorry. We have 2 milestones in week 5 and week 7. In week 9, we have the interest test, and we have the project submission in week 12. Of course, in between, I will be available during office hours if you have or if you need any help for it. As I mentioned, we have our course is starting with an optical fiber and optical communication, which is this green area. Then we have the atomic radiation, we have optical cavity, laser, and finally we have Gaussian beam, which is light propagation. So this is the arrangement of the course. We have 2 revision lectures by the end of the course. You can find everything about the course in this lecture. Sorry, in this file. Okay, let's turn back to our e-learning page. Okay, so as usual, this is all the stuff you need, and this is very important, my dear students. This is a Zoom link which will make you access any of our module tutorials or lectures. So every online session in this module will be accessed using this single link. We have the lectures, lecture scripts. Of course, you know already our lecture script style. We have the recorded lecture. You can visit our recorded lectures either using YouTube or using the e-learning page. We have, this is for the tutorial problem, and this is for the project. This is the project guideline. Let me also open it. Okay, so this is the project guidelines, or what you need about to know about the project style, how you can construct the report, and so on. And also we have this document, which is the project topics. These are a list of topics where you are invited to access these topics and to select what you think the most appropriate for you. And in order to make life easy, I am associating a link per project where you can access a MATLAB code or a COMSOL code or something like that, or COMSOL file that describe the project. What you are going to do, you are not asked to reinvent the project from scratch. What you are going to do is to investigate the already created file. So we are not evaluating your programming skills. That's why we are not going to invest time in building a MATLAB code or something like that. You are going to use an already exist MATLAB code on the over the mass board. And what you are going to do is just to study this code by changing the input and study the output and so on. And the discussion for the final project will be based on your understanding to the variation between the input and the output of the code. This is what we are planning to do. So that's all I think regarding the e-learning page. We already have, of course, the interactive material, the online submission and grading, and the feedback, where you can also use it for giving feedback to us anytime, or for us to give you feedback. So this is generally what we search for in order to make life easy over the e-learning. This is typically what we want. Okay, so now back to our presentation slides and back to this description. Let me again use a pointer. I think we are nearly done. So this is a presentation, of course. What about the lecture? Our lecture is on Thursday by 9 a.m. morning. And our tutorial will be on Monday by 1 p.m. afternoon. And again, this is the link. You find the link over this slide, the 0 slide, also in the e-learning, and I will email you the link, so you can find the link everywhere. Of course, I believe you already know my style in lecture delivery. I start joining the session by 9 a.m. to make you, or to let you end the lecture. Then we have our official start by 9:15, and usually we terminate the lecture by 10:45, which is 15 minutes before the next lecture for you, of course. This is some symbols. I will try to use it from time to time in my slides. FUI for your information, which means that this is not a part of your final exam. DNR, or the revision, is not required, so you will not be asked to do the revision. You just can follow it up to understand the theory. Very important. Of course, this is very important because it's very important. And FS, which is a formula sheet. This equation will be given in the formula sheet. So this is just demonstrative symbols in order to make the slides more interactive. And instead of writing a long sentences, you can just pick up the information by following this sign. That's all I think. That's all for this 0 lecture. Thank you very much for your concentration. And let's start officially our module by investigating the optical fiber, which is again one of the very important innovations in the communication history. Thank you very much and see you in the next lecture.